Okay, so for congruent pairs part 1, number 1, it says for each of the pairs of shapes decide whether or not they are congruent and explain your reasoning. Well, they are congruent if you can use a sequence of rigid transformations that takes one figure to the other. So let's see if we can do that. So if I already have it traced, as usual I do, so I'm just going to line it back up. And I'm just going to see if I can do some rigid transformations to get it to my other one. So I'm going to do a rotation first because I want to get it right in the correct orientation. So what I'm going to do is I'm just going to rotate A, B, C, D around point D 180 degrees. Flip that and the light went off again. There we go. So I'm going to rotate it 180 degrees. So that would be 90, and this would be 180 right here. Alright, so if that's 180 degrees, I can then move it 3 units to the left, which would be 1, 2, and 2 units down, 1, 2. Oh, that lines up perfectly, so we say that yes, it is congruent because it matches perfectly with both figures, okay? So this one is congruent. So let's take a look at our next one. Okay, so if you looked at number 2, you could probably see that, yeah, they're both pentagons, correct? Because they're both 5-sided. But if you look at them, you'd see that A, B, C, D, and E right here has a set of parallel lines, which are AE and CB. But if you looked on the other one, JH and GH, they are not parallel to each other. Remember, parallel lines are equal distance apart, and as you can see, those are not. And we also got some other problems going on here. Because if you look at your shape, even line AB and FG, if you look at the angle here, like right here, and this angle F here, they're not the same size, okay? So A and F would be corresponding parts, but they're not the same size angle. And also, if you look at the different side lengths, for AJF and AE, they're not the same size. So you got the angles and the side lengths are not the same size. So because of that reason, they will not be congruent to each other. Remember, congruent has to be exactly the same. But we found that they don't have a set of parallel lines. The angle lengths are not the same size. The angles themselves are not the same size. For all those reasons, these two figures are not congruent. Okay, so for number 3, I said yes because if you trace triangle ABC, and if you notice it will be the same size because I matched them up real nice and neat. But what I'm going to do is I'm going to use me a sequence of rigid transformations, and I'm going to see if it'll map perfectly to that now. So I'm going to line this back up, and I'm going to use the origin as my point of rotation, and I'm going to rotate that 90 degrees. So if I rotate it 90 degrees, all the way 90 degrees, it lines up here like this. Then I can just, from there, all I have to do is translate it down 2 units. Hold on, I got to get my paper straight here. Let me do that again. 90 degrees. Get it all lined up, my origin, and I have to move it 1 whole paper turn. So that's going to put it right there. So then if I translate it 2 units down, let's go 2 units down. Can you can see that. If I go down to, like this is my point here, I'm going to take it 2 units down, so that would be 1 and 2. Then all I have to do is translate it 3 units to the left, which that would be 1, 2, and 3, and you will see that it lines up perfectly on there. So yes, it would be, you can use a set of rigid transformation to take one figure to the other. So because I used that set of rigid transformation, that means I've preserved all the side lengths. All the side lengths still remain the same, and all the angles remain the same. So because it lines up perfectly, once again, I would say, yes, they would be congruent. Okay, so for number 4, just eyeballing it, guys, just by looking at it, we already know that this octagon, they're both octagons, right? But this one is much larger than the other. Even though the angle sizes are still the same, because the side lengths are not the same, it will not be a rigid transformation. So if you looked at AB, you'd see that's exactly 2 units. And if you look at the corresponding line, IJ, you can see that is not a whole 2 units here. Okay, just by looking at that, you know right away that it is not going to be, excuse me, it will not be a rigid transformation that will be able to take it to it. So they will not be congruent.